The Williamson ether synthesis is a straightforward reaction. It's just a typical SN2 substitution. To do this, we use an alkoxide ion and react it with an alkyl halide. The alkoxide ion is easy to get. We just use an alcohol and mix it with sodium or potassium. This will react as the nucleophile. Since this is such a polar bond, there will be a partial positive on the carbon, partial negative on the halide. When this reaction occurs, the result is an ether and a halide ion. This is generally done for primary halides. Secondary halides, this reaction can occur. It's perfectly possible for this to undergo an SN2 reaction if it were a secondary halide. However, since this is such a strong base, for a secondary halide, now the elimination reaction is something that becomes a competitive factor in trying to get just this SN2 reaction to occur. So unless there is some specific reason why the SN2 reaction would be preferable to the elimination reaction, which it is possible on some things, I suppose, but typically I guess if you needed to get it to work for a secondary halide, it would probably work in a situation where they were easy to separate by boiling point or freezing point or some other method. Then it would probably be okay, and as long as the materials weren't too expensive, then it might be something to consider doing. But otherwise, this is generally only done for primary halides because of the high yields. Secondary halides, they tend to be poorer yields because of that elimination reaction that can occur.